Question 1. The apparent daily rising and setting of the sun, moon, and stars is caused mainly by A. The sun orbiting the Earth.
B. The Earth rotating on its axis.
C. The moon's orbit.
D. The expansion of the universe.
The answer is B. The Earth rotating on its axis. The whole sky appears to wheel from east to west once a day because the Earth spins on its axis from west to east. The objects are nearly fixed. It is the ground beneath us that is turning.
20 questions to test whether you could pass the Astronomy DSST exam and save hundreds of dollars by skipping the full college course. Think you've got what it takes? Get 16 right and you're likely ready for the full exam.
Question 2. The seasons on Earth are caused primarily by A. Changes in Earth's distance from the sun.
B. Changes in the sun's output.
C. The tilt of Earth's axis. D. The phases of the moon. The answer is C. The tilt of Earth's axis. Earth's axis is tilted about 23.5 degrees, so as it orbits, each hemisphere leans toward the sun for part of the year and away for the rest. That changing angle of sunlight, not our distance from the sun, drives the seasons. Question 3. A light year is a unit of A. Distance. B. Time. C. Brightness. D. Mass. The answer is A. Distance. Despite the word year, a light year measures distance. The distance light travels in 1 year, about 6 trillion miles. It is used because the distances between stars are far too large for ordinary units. Question 4. Which of the following lists the correct order of these layers of the sun from the inside out?
A. Corona, photosphere, core.
B. Photosphere, core, corona. C. Corona, core, photosphere. D. Core, photosphere, corona. The answer is D. Core, photosphere, corona. The sun's energy is produced in the core at the center. It then works outward to the photosphere, the visible surface, and finally to the corona, the faint outer atmosphere seen during a total eclipse.
Question 5. The energy radiated by the sun is produced by A. Burning of coal and gas.
B. Friction from its rotation. C. Nuclear fusion of hydrogen into helium.
D. Chemical reactions in the corona.
The answer is C. Nuclear fusion of hydrogen into helium. Deep in the sun's core, immense pressure and heat fuse hydrogen nuclei into helium, releasing enormous energy. This nuclear fusion, not ordinary burning, is what powers the sun and all main sequence stars. Question 6. The phases of the moon are caused by A. The changing amounts of the sunlit side we see as the moon orbits Earth. B. The shadow of the Earth falling on the moon. C. Clouds in Earth's atmosphere. D. The moon passing through the sun. The answer is A. The changing amounts of the sunlit side we see as the moon orbits Earth. Half the moon is always lit by the sun. As the moon orbits Earth, we see different fractions of that sunlit half, which gives us the cycle from new moon to full moon. The Earth's shadow is not involved. Question 7. A solar or lunar eclipse does not happen every month because A. The moon is too far away. B. The moon's orbit is tilted relative to Earth's orbit. C. The sun is too bright. D. The Earth spins too fast.
The answer is B. The moon's orbit is tilted relative to Earth's orbit.
The moon's orbit is tilted about 5 degrees to the plane of Earth's orbit. So usually the moon passes above or below the perfect lineup. Only when the three bodies align closely enough does an eclipse occur.
Question 8. Which group lists only terrestrial, rocky planets?
A. Jupiter, Saturn, Uranus. B. Earth, Jupiter, Neptune. C. Saturn, Mars, Neptune. D. Mercury, Venus, Earth, Mars.
The answer is D. Mercury, Venus, Earth, Mars.
The 4 inner planets, Mercury, Venus, Earth, and Mars, are small, dense, and rocky. The outer giants, like Jupiter and Saturn, are large and made mostly of gas and liquid, so they are not terrestrial planets. Question 9. The tides on Earth are caused mainly by the gravitational pull of the moon, and to a lesser extent, the sun. B. The rotation of the Earth alone. C. Winds blowing across the oceans. D. Changes in air pressure.
The answer is A. The gravitational pull of the moon, and to a lesser extent, the sun. Tides arise because the moon's gravity pulls harder on the near side of Earth than the far side, stretching the oceans into bulges. The sun adds a smaller effect, strongest when sun, Earth, and moon line up.
Question 10. According to Kepler's laws, the orbit of a planet around the sun is a perfect circle. B. A spiral. C. An ellipse with the sun at one focus.
D. A straight line.
The answer is C. An ellipse with the sun at one focus. Kepler showed that planets travel on ellipses, slightly flattened circles, with the sun sitting at one focus rather than at the center. This replaced the old belief that orbits had to be perfect circles. Question 11. What property of a star does its color tell you most directly? A. Its distance. B. Its age in years. C. Its chemical makeup only. D. Its surface temperature. The answer is D. Its surface temperature. A star's color reveals its surface temperature. Blue stars are the hottest, while red stars are the coolest. Our yellow-white sun sits in the middle of that range. Question 12. On the Hertzsprung-Russell diagram, the diagonal band where most stars, including the sun, spend most of their lives is called the A. The red giant branch. B. The main sequence. C. The white dwarf region. D. The horizontal branch. The answer is B. The main sequence. The main sequence is the long diagonal band on the Hertzsprung-Russell diagram, where stars fuse hydrogen in their cores. Stars like the sun spend about 90% of their lives there. Question 13. A typical low-mass star like the sun will end its life as a black hole. B. A neutron star. C. A white dwarf. D. A supernova remnant.
The answer is C, a white dwarf. After swelling into a red giant and shedding its outer layers, a sun-like star leaves behind a hot, dense core called a white dwarf. Only much more massive stars end as neutron stars or black holes.
Question 14. A supernova is
A. The explosive death of a massive star.
B. The birth of a new planet. C. A collision between two galaxies. D. A type of solar eclipse.
The answer is A, the explosive death of a massive star.
A supernova is the violent explosion that ends the life of a massive star, briefly outshining an entire galaxy. It scatters newly forged heavy elements into space, seeding future stars and planets.
Question 15. Stars are born in A. The cores of black holes.
B, the rings of giant planets.
C. The empty space between galaxies.
D, clouds of gas and dust called nebulae.
The answer is D. Clouds of gas and dust called nebulae. Stars form inside cold, dense clouds of gas and dust called nebulae. Gravity pulls a clump together until its center grows hot enough for nuclear fusion to ignite, and a new star switches on.
Question 16. The galaxy that contains our solar system is called the
A. The Andromeda Galaxy. B. The Milky Way. C. The Whirlpool Galaxy. D. The Large Magellanic Cloud.
The answer is B, the Milky Way.
Our Sun is one of a few 100 billion stars in the Milky Way, a spiral galaxy. The faint band of light we call the Milky Way in the night sky is our view edge-on into its disk.
Question 17. The most common evidence that the universe is expanding is that distant galaxies show a blue shift in their light.
B. Steady, unchanging brightness. C. A loss of all light. D. Red shift in their light.
The answer is D, redshift in their light. Light from distant galaxies is shifted toward longer, redder wavelengths, a redshift. The farther away a galaxy is, the greater its redshift, which tells us those galaxies are moving away as the universe expands.
Question 18. The theory that the universe began in an extremely hot, dense state and has been expanding ever since is called A. The Big Bang Theory. B. The Steady State Theory. C. The Nebular Hypothesis. D. The Theory of General Relativity. The answer is A. The Big Bang Theory. The Big Bang Theory holds that the universe began about 14 billion years ago from an extremely hot, dense state and has been expanding ever since. The cosmic microwave background is its leftover glow.
Question 19. The faint glow of microwave radiation coming from all directions in the sky, considered strong evidence for the Big Bang, is the
A. The solar wind. B. The zodiacal light. C. The cosmic microwave background. D. The aurora. The answer is C. The cosmic microwave background.
The cosmic microwave background is leftover heat from the early universe, now cooled to just a few degrees above absolute zero. Finding it in every direction confirmed a key prediction of the Big Bang.
Question 20. Our solar system is located
A. At the exact center of the Milky Way.
B. In one of the Milky Way spiral arms, far from the center.
C. Outside the Milky Way entirely. D.
Inside the Andromeda Galaxy.
The answer is B. In one of the Milky Way's spiral arms, far from the center.
The Sun sits in a spiral arm of the Milky Way, roughly halfway out from the galaxy's crowded center, about 26,000 light-years away. We are in a fairly ordinary neighborhood of an ordinary spiral galaxy, not at its core.
So how'd you do? 11 or fewer, and there are real gaps to close. 12 to 15, you're on a solid track. 16 or more, and you're likely ready for the real thing. Get your full adaptive learning plan at flyingprep.com.